In this video, I just want to show an example of how to evaluate trigonometric functions for some angle in radians, just to kind of walk through the steps and remind us of the tools we have available. So let's suppose that you are asked to evaluate sine of 7 pi over 6. So you're given some angle in radians. Remember, radians really are the best way to work with our angles, and they are the standard moving forward in mathematics and sciences. So make peace with radians and really kind of get used to taking advantage of all they have to offer. So for example, remember, if you're trying to evaluate a trig function, we really want to know the reference angle. If we're not going to plug this into the calculator, if it's an angle we can identify from the unit circle, we want to identify the reference angle. And when your angle is in degrees, you often have to kind of draw out the picture, and it becomes a little more involved. With radians, the reference angle is given as long as it's in a format like this. This sucks. In this video, I want to cover an example or two on how to evaluate a trig function given some angle in radians. So suppose you are asked to find sine of 7 pi over 6. Well, if you recall, to evaluate a trig function at some angle, one of the most effective ways is to make use of the first quadrant of the unit circle and that little trick that all students take calculus. That'll help us remember in which quadrant each trig function is either positive or negative. All of that hinges, though, on knowing the reference angle. And this is where one of the areas, rather, where radians can really excel over degrees. When you have an angle given to you in degrees, to determine the reference angle, you often have to draw a picture to kind of figure out what is the reference angle, and therefore you know where to look at when you're consulting the unit circle. When you're given an angle in radians, especially in a format like this, the reference angle is staring us right in the face. So we know that for this angle, the reference angle is pi over 6, and we just happen to have 7 of those pizza slices. So right off the bat, we can identify the appropriate ratio for this sine function. Let's just quickly sketch up the unit circle for pi over 6. So let me put the point first. We have a cosine of root 3 over 2 and a sine of half for a pi over 6 angle. Cosine is root 2 over 2 and sine is root 2 over 2 when our angle is pi over 4. And our cosine is half and our sine is root 3 over 2 when our angle is pi over 3. Remember, those come from the special right triangles. In a previous video, we kind of showed how to generate those values. So please take a look if you haven't seen it. So knowing that I've got a reference angle of pi over 6, I want to kind of identify, well, where is that angle? Remember, this is 0 and halfway around the circle in radians is pi. Now, if you're still uncomfortable counting around the unit circle in radians, here's a little trick that I find very useful. Once you know how you've cut your pizza, you've cut it into pi over 6 size slices, right? We just happen to have 7 of them. Then relate these anchor points, right? These anchor points, relate them to the way you've cut your pizza. In other words, to get to pi, I want to know how many, I don't know if I have room here, how many pi over 6 slices does it take to get to pi? Well, that would be 6 of them, right? You would need 6 of those slices because the 6's would cancel, leaving you with just pi. So I know if I go halfway around the circle, I've gone 6 of these slices. That means one more would put me at 7 of these slices. And I know that this angle here would be one additional pi over 6 slice. So again, I can see that the reference angle is indeed pi over 6. Okay, so if we want 7 pi over 6, again, it's knowing the reference angle. We can already see that the sine value should be a half. We then just need to determine, okay, should it be positive or negative? Remember, all students take calculus. And so if my angle is terminating in quadrant 3, only tangent is positive there. Everybody else is negative. So this final answer is going to be -1/2. All right, let's try another example. What if we were asked to find cosine of 19 pi over 6? Okay, so that's kind of daunting, and we don't maybe have an idea yet where that is. But I can tell you the reference angle, right? We can see that we, again, have cut the pizzas into pi over 6s. Let's change that angle. Let's do something a little different. How about we ask for cosine of, let's say, like 21 pi over 4s. Okay, so some crazy angle, but let's change the reference angle. So I can still identify it really quick. I've cut this pizza into pi over 4 size slices, right? And we know at a pi over 4 angle, the cosine is √2/2 and the sine is √2/2. So automatically we know the answer is going to be √2/2. The question is, should it be positive or negative? That's what we got to figure out. That comes down to figuring out what quadrant 21 pi over 4 lands in. So let's start counting our way there. Again, we've got our anchor points, 0, and if you go all the way around, it's 2 pi. 21 pi over 4 sounds like a lot of slices. So I think we're going to have a lot of whole pizzas here. I think we're going to have to take a lot of laps around the circle. So we can relate the pi over, or the pi, the half a pizza, to pi over 4 slices. Wouldn't that require 4 of them, right? Because the 4s would cancel, leaving us with just pi. So I know that it takes 4 of those slices to get there. If I were to go all the way around the circle and have a whole pizza, well, we could just double that amount, or we could see that to get to 2 pi in terms of pi over 4 slices, I'd have to have 8 of them, wouldn't I? Because the 8 over 4 would cancel to 2. So I know there's 8 of these slices in one whole lap around a circle. Okay, so we've got 8 pi over 4 slices here. All right, so I'm just going to count my way up to 21. If I go one whole pizza, that's 8 pi over 4s. Another whole pizza would be 16 pi over 4s. I just added another 8. Another whole pizza would be, 24 pi over 4. So that's too many. Okay, so let's back off. 2 pizzas was 16 pi over 4. So if I go 4 more, I am at 20 pi over 4s, and then I need 1 pi over 4. Boy, that was a big number, and I hope I counted it out right. But I think we're landing in quadrant 3. I think this is where 21 pi over 4 slices. Right, so again, I think the pizza reference helps. You've got pi over 4 size slices, and you've got 21 of them. It would fill 2.5 pizzas and 1 extra slice. Okay. We knew the answer was √2/2. We just had to figure out where the heck that was so we can figure out whether it should be positive or negative. And because we remember all students take calculus, and we landed in quadrant 3, then only tangent should be positive there. The cosine needs to be negative. All right, so final answer, cosine of 21 pi over 4, is a negative √2/2. Okay, so again, first quadrant of the unit circle, and all students take calculus. Very powerful. And what helps me a lot with counting the unit circle and radians is remembering to utilize these anchor points. Once you've identified the reference angle, then rewrite pi and 2 pi in terms of those units. So that way you know exactly how many slices fit in half a pizza or a full pizza. All right, keep up the good work.